Take a look at this. This is the path Artemis II will take to the moon, and it looks very different from Apollo. Humanity is returning to the moon in just hours at the time of this recording. But this mission isn't Apollo, and the way it's getting there tells a much bigger story. And more importantly, this may not even represent the most advanced way we're capable of traveling in space today. What you're seeing here is the current approach, the official system. The framework NASA is using to move humans beyond Earth again. And when you compare it to Apollo, the differences are not just technical, they reflect a completely different objective. Apollo was about getting there fast. Artemis is about staying. This mission marks the first time in over 50 years that astronauts are heading back toward the moon. But Artemis II is not a landing mission. It's a full systems test with a crew on board. The astronauts will launch aboard the Space Launch System, travel out to the moon, perform a flyby, and return to Earth. There's no landing. Instead, this mission is about validation. Every major system is being tested under real conditions. Navigation, life support, communication, thermal protection during re-entry. This is the step that determines whether Artemis III can actually place humans back on the lunar surface. And that brings us back to this path, because the way Artemis gets into the moon's orbit is just as important as the fact that it's going at all. What you're looking at here is called a free return trajectory. This is a carefully designed orbital path that loops around the moon and naturally brings the spacecraft back to Earth. Which means if something goes wrong, if there's a systems issue or a loss of propulsion, the crew can still return safely without needing a major correction. It's a built-in safety mechanism. You'll also notice that looping motion near Earth before heading out. That's not wasted movement, that's orbital alignment. The spacecraft is building the exact position, velocity, and timing needed to intersect with the moon's gravitational field in a very precise way. This is controlled, calculated motion. Now, this is where the comparison becomes clear. If you look at the Apollo trajectory, it's much more direct. Apollo missions used what's called a translunar injection, a powerful burn that essentially sends the spacecraft on a direct path to the moon. Minimal looping, minimal complexity. It was fast and efficient for its time. And it was designed around a specific goal: get there and get back. Now look at Artemis. You're seeing more curvature, more shaping of the path, more interaction with gravity. This mission is using orbital mechanics more deliberately. Instead of relying primarily on raw thrust, Artemis is working more with gravitational influence and energy efficiency. Apollo was about speed and execution. Artemis is about sustainability and repeatability. And it's worth noting the entire discussion is based on conventional propulsion: chemical rockets, controlled burns, gravitational assists. If more advanced propulsion systems exist or emerge in the future, trajectories like this may eventually look very different. But for now, this is the system being used, and it's what's opening the door forward. If Artemis II is successful, it clears the way for Artemis III, and that's where things will change. Because Artemis III is planned to land astronauts on the moon again. But unlike Apollo, that's not the end goal. The long-term vision goes far beyond a single landing. NASA is working toward building infrastructure around and on the moon. This includes the Lunar Gateway, a space station that will orbit the moon, and surface systems and habitats. The missions around the moon mostly and initially will be focused on the lunar South Pole, where water ice has been detected. You see, water is key. It can be used for life support, converted into oxygen, and even broken down into hydrogen and oxygen for fuel. which means the moon could become a refueling point, a staging ground for deeper space missions, including Mars. So, what we're looking at here isn't just a mission, it's a transition from exploration to presence, from short duration visits to long term systems, from proving we can go to building the ability to stay. Artemis II may not land on the moon, but it may be one of the most important missions in the entire program. Because if this works, everything that follows becomes possible. We're not just going back to the moon, we're learning how to live beyond Earth. If you're following the future of space, meteorites, and what it all means here on Earth, make sure you're subscribed to the channel. And if you want to hold a piece of that bigger story in your hand, we carry authentic meteorite specimens, including Campodocello and Nantan, over at thecrystalearthgallery.com. Link is in the description. Thank you, and until next time, my friends, be well.